always wanted to know how old a sea turtle is. Comment below if you know what movie that is from. So we have a sea turtle here, and today we're looking, amigos, at what the lift coefficient of a turtle is. So first of all, I put the background in blue, so it looks like it's swimming around. That's pretty cool. I was impressed myself. But the reason why I wanted to look at the lift that a turtle was producing is because when you look at a shell, it looks fairly wing-like. So I was interested in seeing whether this would be producing a lot of lift or not. So we have a turtle here which is fairly, it's almost at an angle attack of 0 degrees. We have a few clip planes behind, X planes, and a few things first will pop out. First, the wake is fairly small. Secondly, it's quite well behaved. You see there's a little bit of unsteadiness to it, but it's not nearly as bad as like a typical bluff body like a cylinder. It's not as good as a wing because wings don't really have unsteady wakes unless you go into stall conditions. But in pre-stall conditions, the wakes are very steady. So this is sort of in between a wing and a bluff body. Let's look at other planes to see if we can see any lift being produced. So we have two Y planes here, one going over the middle of the turtle, one going over the flipper. So the reason why is because the flippers, they're used to maneuver, they're used to produce lift and go up and down. The shell, on the other hand, I thought maybe they might be producing a little bit of lift because of its structure. But let's talk about this separately. First of all, the flipper is doing pretty nicely. Like it only goes, it's fairly steady, the wake. Only once you go downstream, it starts to break down, which is fairly normal. So the flipper is quite good. The shell, on the other hand, is not nearly as good as what I might have expected. So I thought that perhaps the flow would stay attached better than what it does, but it doesn't. You can see that once you get past maybe not even 60% of the shell, it starts to separate and there's a lot of recirculation and a very big wake behind. The head of the turtle seems to produce a lot of separation as well, considering how small it is. So that's probably affecting the shell itself. If you took the head off and you put maybe a turbojet engine inside the turtle instead, you might be able to produce enough thrust to keep the flow attached if it's moving fast enough, so you can get a flying turtle that way. As it stands, though, it doesn't look like it's producing too much lift, but we'll get to that in a little bit. So now we have that Y plane going through the middle of the turtle, and we're looking at it from the side because I want to look at from this point of view because you get a good idea as to how much lift something's being produced from the side. If you look at where the wake is going, if it's going up or down. The general rule of thumb is if the flow is going down, then you know that the object is producing lift. If the flow is going up, then you know that the object is producing downforce. In this particular case, the turtle itself, the wake kind of drifts up a little bit. It doesn't go down very much, and it's indicating that there's a little bit of downforce being produced. And I can confirm that the lift coefficient of this turtle is about minus 0.2. So that makes sense. We have the flow going up a little bit, so it's not producing a huge amount of downforce, but it is a little bit, and minus 0.2 is a little bit of downforce. So turtles are actually like negatively producing lift. They could handle around corners perhaps, they've got a lot of downforce, but in terms of flying in the skies, as they stand now, unmodified, probably not. They're probably better suited to racing. So now we have a Z-plane going through like just the turtle's head, the top part, and then like the top part of its shell. And I wanted to look at this point of view because we wanted to see if there's like a von Karman street being formed. So there is unsteadiness and there is periodicity to the unsteadiness, but it's not a very convincing von Karman street. Like you can see that there isn't like this typical vortex structure rolling up. So that's probably due to one, the rose number is probably a little bit too low, but two, the shell is probably a little bit too streamlined to produce a very coherent von Karman street. It has some periodicity to the shedding, but not complete coherency. So let me know what you think about turtles, if it would be a good idea to convert it into a flying airplane with a turbojet, and what you would do to make it a flying plane. Would you strap it in on the top of the turtle? Would you put the turbojet underneath? Would you take the turtle's body out and put the turbojet right into its shell and get the flippers? Let me know. So if you want to get better at CFD, let me know. Check out the description in the link. And if you want to get better at theory, check out the description as well. We've got courses there that you can take. And I'll see you next simulation. Peace out, amigos.